Good day. Thanks everyone for coming along. So today I've got Professor Marit Kragt presenting. Many of you would know Marit. She's an agricultural economist here at the University of Western Australia, so you would have seen her around. I think the talk today is going to be quite interesting. Marit's got quite a wide-ranging knowledge. So it goes from agricultural adoption through to farm system analysis and non-market valuation, and probably about everything else in between. Marit's also the director of 𝒐𝒐𝒍. 𝒐𝒐𝒍's newly established Centre for Agriculture, Economics and Development. It's based here at the University of Western Australia, but I think it's sort of Australia-wide, more or less, as far as what it can do or what it offers. So yeah, essentially it aims to help with sort of policy advice and sort of agriculture economic research. So I think it also helps students or even staff that are here at the University of Western Australia. So if that's something that interests you, I think there is a website that you can search up, so you can check that out. Anyway, today Marit's going to talk about using flies to turn livestock waste into profit. So that's quite interesting. If it's a worthwhile thing, that's really good for farmers and the like. So the topic seems, from the abstract, seems pretty interesting. It's covering pest management, sort of emissions management, crop production and nutrient leaching. So I think there's going to be a fair bit here for us to hear about. So yeah, I'll pass over to you, Marit, and yeah, thank you.
Thank you very much, Michael. So I've just popped the centre website in the chat, and that's a Centre for Agriculture, Economics and Development that we set up last year. And we're working hard to establish that website, that centre, and make it grow the centre. So before I start today, although my background is Tasmania, I am joining you from the 𝑺𝒄𝒉𝒐𝒐𝒍 country here in Perth, and most of you will be on that country as well. So I'd like to acknowledge that most of us are meeting on 𝑺𝒄𝒉𝒐𝒍 country, and that the 𝑺𝒄𝒉𝒐𝒍 people remain the spiritual and cultural custodians of this land. So while Michael lets latecomers in, I will share my screen to start this presentation. So that should just be uploading in a moment. And if you're just joining, please mute your microphone. It's not automatically muted. So my name is Marit Kragt. I'm an associate professor at the UWA School of Agriculture and Environment, and also director of the Centre for Agricultural Economics and Development. But today I'm going to talk to you about this very interdisciplinary project that we are just wrapping up as we speak, on using black soldier fly to turn livestock waste into hopefully profitable products. So this project has multiple facets, but overall we're trying to answer whether we can use black soldier fly and black soldier fly farming as a low-cost option to turn agricultural waste, and we're focusing on livestock waste, into a high-quality fertilizer and potentially even feed products. The feed aspect of this research is purely a literature review, but the fertilizer part has involved a lot of testing and trials. So for those of you who are just joining now, if you have any questions while I'm presenting, please drop it in the chat. I won't look at that while we're talking, but I will. It's just a good way to keep track of all the questions later. So the overall question this is a big project with lots of people from UWA, but also other organizations. So it's supported by an R&D for profit grant that Sasha Jenkins led. So I should acknowledge that this this grant was attracted by 𝒉𝒎, funded by the Australian government, Department of Agriculture, managed by Australian Pork, with investments from the AMPC, Meat Processors Corporation, Australian Eggs, AgriFuture, Dairy Australia, and the FRDC, that's the Fish RDC. And our industry partner is Future Green Solutions, and I see that Sophia is also on the line, so we can ask Sophia questions at the end if you would like. And the Queensland government of Department of Agriculture was also involved in doing some of the trials. So, and this project had multiple objectives. So we are developing this black soldier fly farming technique and try to optimize the way we grow black soldier fly on livestock waste. But we also then are going to investigate, well, what effects does that BSF-based, the residue from the larvae growing process, has on soil quality, on greenhouse gas emissions, on pest emergence, and is it a good fertilizer? Does it enhance crop yield? Then there is an engineering component where the BSF-based is turned into an actual fertilizer product, and the engineers on this project have done lots of trials into granulating or pelletizing this fresh product. And our team, the economics, has looked at potential barriers and drivers to adopting BSF technology on either for waste management, but also adoption barriers and drivers for farmers to use black soldier fly fresh as a fertilizer. So the overall aim is to develop this fresh as a fertilizer, but also to get that adopted by farmers. So we had a very multidisciplinary research team. And what Michael said at the start is very true for my research. I always conduct this interdisciplinary research, lots of different types of disciplines, and typically I'm the person who then tries to talk between the different disciplines. So we had the industry partner, Future Green Solutions. Any of you who've been to the Shenton Park Open Days may have seen the black soldier fly facility that they operate there. Then at UWA, we had a team of plant scientists, soil scientists. So Sasha Jenkins, for example, Megan Ryan was involved in this research. Dan and Joe as postdocs who now work at the GDA. We have soil microbiology. We had agricultural engineers led by Andrew Gazomi, and a team of economists, myself, Fiona Dempster, and Faye Rola Robson working on this project. Then at the Department of Agriculture at DPERT WA, we had an entomologist. At Queensland DEF, we had a plant nutrition expert, and we also had a consulting firm, Scholexia, involved in doing the biosecurity and regulatory reviews. So those were literature reviews. So this is a team effort that I'm presenting here, by no means my work alone. So I'll start by telling you a little bit about how this black soldier fly farming process works. So we have, I hope you can see my mouse, we have the manures, the livestock waste arriving, and the black soldier fly neonates are seeded on this manure, and the larvae develop into, on the one hand, live larvae, which could be used for potential products, but the focus of this project was on the black soldier fly fresh, and that is the larvae poo, the undigested feed, and the exoskeleton of the larvae. So it's a mix of materials, and we were interested in, can we use that fresh as a fertilizer or a soil amendment? Now, and of course, when we use that as a fertilizer and grow and graze the crops by livestock, the livestock feed is the livestock waste is processed by black soldier fly again, we can nicely close that loop, which was the title of our project, closing the loop between waste and agricultural production. Now, the project proposal focused largely on this final end. Can we use the frass as a fertilizer? It turned out that this bit here, making the larvae even develop and having them grow on livestock waste, was extremely challenging. So I'm going to talk to you a little bit about the different steps that we've undertaken in this project, and starting with growing the black soldier fly on manures. So that process took a few years to test and optimize the growing processes. And all this testing was done at Future Green Solutions by Sophia and colleagues. And they had to test, well, what is the optimal moisture rate to grow these larvae on manures? What's the right mix of manure substrates? So you could have individual pork manure, poultry manure, dairy manure, or you could have a mix of these manures. You can have different type of substrates, and I'll show you some results in a moment. And the type of livestock manure had a big impact on the yield of the larvae and the waste reduction potential of these black soldier fly larvae. And they also had to test, for example, what humidity is the best for growing these larvae. What's the best seeding rate of the larvae on the substrate? What is the best temperature to grow these larvae on? So lots of trial and error to get those processes right. And we grew black soldier fly larvae on a range of different livestock wastes that were collected from around the Perth area, and compared that to growing the larvae on food waste. And that was a process that Future Green Solution has already been working on for a while, and is pretty confident on that is an optimized product. So we're comparing it to because in the next couple of slides, you're going to see clean substrate, and that is the food waste substrate, which is a mix of food waste. So I'm going to start showing you a few slides with results. So on this bar graph, you see on the left-hand side the clean substrates, which achieved about 85% of waste reduction after 7 days of processing this waste with larvae. So you can imagine if you have 1 ton of food waste and reduce that by 85%, you get rid of a lot of your waste problem. Manure on the right-hand side is pork manure, pure 100% pork manures. Took a bit longer to digest by the larvae. So after 7 days, there was about 65% waste reduction. But if you left that longer, waste reduction was increased by nearly the same level as the clean subs, as the control, nearly 85%, reaching more than 80% after 14 days, which is the middle column there. So I'm just imagining this intensive piggery, for example, that has a stockpile of manure that they need to get rid of for various reasons, because there is odor nuisance from the waste, because it emits greenhouse gas emissions, because it is costly to stockpile the manure. Treating it with black soldier fly, we are showing here that can significantly reduce the volume of your manure pile. Oh, I forgot that I had that one. So let's go to some other results. The 80% reduction that we found in pork was copied for most of the different dairy manures, which is the blue bars over here. But it depends on what type of waste was used. So before I just showed the fresh 100% pork manure. In this trial here, we looked at, well, does it matter whether we use the fresh manure or the separated solids or the stockpiled older dairy waste? And what we see is that the dairy waste from the waiting area, or the accumulated solids, which is which had been stockpiled for about 3 months, had a significantly lower waste reduction potential. So that tells us that it's best if you treat it with black soldier fly immediately, at least for the dairy waste. But when you look at the green bars, which is paunch, you see that the waste reduction potential is a lot lower for that type of waste, and that was because paunch was quite wet. It had a lot of undigested materials in it, which were not easy to convert for those black soldier fly larvae. And I have a photo of that here. Paunch waste is the contact of a cow's stomach. And you see a photo here. It had a lot of inorganic materials that could not easily be digested by the black soldier fly larvae, and therefore their waste reduction potential was lower. And we had similar findings with any materials that had too high a moisture content, like this fish offal. So we're doing further testing with that. We also did tests by inoculating the waste with, for example, probiotics to see if that worked. Had limited benefits, but we also tried different mixtures of waste, both livestock, various components of the livestock waste, but also mixing livestock waste with food waste to increase the waste reduction, but also increase the output of the larvae, which is what we were interested in to produce the 𝒒Ⅎ𝒆 and the potential fertilizer, which is where I'm going now. So we've done that bit of testing the black soldier fly production on the livestock. The other component of the research was testing the resulting 𝒒Ⅎ𝒆, and could that 𝒒Ⅎ𝒆 be used as a fertilizer? So big team of people involved in this. You see Matt here at Queensland Deaf. I think this is Joe seeding in the field trial. We did pot trials on a range of crops, and also field trial on wheat crop and ryegrass crops, and tested then how those plants reacted, but also how the soil responded to different rates of 𝒒Ⅎ𝒆 fertilizer being added. I'll just show you a few photos of how that worked. We're still writing up the results of those tests, and also I think pictures are much nicer than lots of tables. So here's a beautiful photo of the field trial having been seeded in, and you can see the wheat and the crops coming up here with lower rates of fertilizer added and higher rates of fertilizer added. And on the next slide, I will put those next to each other. A bit of bad luck during that field trial. You see all the netting here on the wheat crop. Unfortunately, birds got into the field trial, into the bigger nets, and started eating the crop, which is one of the hazards doing field trials that any of you doing field trials will be familiar with. So that was a bit unfortunate for the wheat trial. But we still had plenty of results on that 𝒒Ⅎ𝒆 fertilizer testing from the field trials, showing that, and you have 3 photos here with no 𝒒Ⅎ𝒆 and increasing rates of 𝒒Ⅎ𝒆 application. That clearly shows that crop yield and crop growth was enhanced when we added that 𝒒Ⅎ𝒆. And that was interesting because objectively, if you lab test the 𝒒Ⅎ𝒆, it has a relatively low NPK content compared to synthetic fertilizers. So we suspect that there is more going on in maybe helping the soil microbial activity to enhance that crop growth. But that is the area of Sasha, and I don't know if she's on the line to answer any questions on that, but that is also being written up as we speak. Now, I said at the beginning that we suspect that this 𝒒Ⅎ𝒆 has multiple benefits, not only as a fertilizer enhancing the crop yield, but also potentially reducing the emergence of pest species. So, and one of the pest that is a big nuisance here in Western Australia is the emergence of stable fly from chicken manures. In the Gingin area, there's a lot of chicken farms, and stable fly emergence is a problem over there. And we tested whether, well, does stable fly emerge when we use fresh instead of manure on applied to our crops. And the experiments done by David Cook showed that there was nearly no emergence of stable fly in the black soldier frass, despite there being lots of chicken farms around the area, and especially compared to raw poultry litter, where we had about 10 stable flies developing per replicate compared to less than one in the black soldier fly cases. So that's a really positive result. If anything, we can use the black soldier fly technology to process the poultry litter to reduce the emergence of stable fly. Another potential benefit that we wanted to look at is the emissions of greenhouse gases. And I must admit, I have not seen the final results of these tests as either. But Jen Middleton and Sasha Jenkins did tests where they compared emissions of CO2 and N2O from raw chicken manure compared to urea, compared to black soldier fly frass, showing that emissions were a lot lower from the frass compared to the raw manure, but maybe not as low as urea. So I think there is a bit more work to be done here on whether the frass could be a potential mitigation strategy, yes or no. Now, of course, as an economist, the first thing I think when I see these sort of results are, well, is this worth it in terms of the cost and the benefits, the cost of using this black soldier fly and the benefits of reduced stable fly, reduced greenhouse gas emissions. So that is where our team came in. I'm going to show you a few more slides about the socioeconomic research, since that is my area of expertise. And that looked at two stakeholder groups, if you want, in this whole story. On the one hand, we considered the waste producers, which is the livestock farmers, and whether they would be interested in using this black soldier fly technology to manage their livestock waste. Now, I'm originally from the Netherlands, where managing your livestock waste is a big cost component for any livestock producer, because waste management is highly regulated in Europe. In Australia, not so much. So I was just distracted by the chat, and I do have that information, and I will answer that at the end. So in Australia, there's not as much regulation about how you can apply your livestock waste, how you need to manage your livestock waste, especially not in more extensive livestock systems. But we were interested whether farmers would consider using this black soldier fly to manage their waste, and especially in those intensive dairy, piggeries, or chicken farming systems. Now, it turned out, after a range of interviews and surveys, that waste producers had very little idea of what the costs are of their livestock management. So cost would include some financial cost, labor, stockpiling cost, collecting and transporting perhaps of waste to a processing facility in some cases, but also non-financial costs, so health impacts, odour, nuisance on your neighbors, greenhouse gas emissions. But it turned out that most people we spoke to had no idea what it cost. So if you don't know how much your waste management costs, how on earth are you going to evaluate whether using a black soldier fly to reduce those costs is worthwhile or not, right? And also, it was the costs were differed a lot between different livestock systems, and we had a team getting their head around even what sort of waste management strategies are currently used by livestock producers, which took us a while to get our head around because it's not easily accessible. There's no guide for waste management in Australian livestock systems. But despite waste producers not really knowing how much their waste management costs, they were still interested in this black soldier fly technology. We were keen to investigate whether these farmers, both the waste producers and potential end users, had an inherent aversion to something to do with flies. And that hypothesis came from the start of the project to talking to a range of people who had a bit of a yuck attitude to the idea of using flies. But it turned out that farmers didn't have any of these, didn't have a negative attitude. They actually thought that BSF technology was a potentially very sustainable technology to use in agriculture. However, because of cost concerns associated with transporting manure to a black soldier fly facility, but also biosecurity concerns associated with the rules and regulations and the cost of transporting waste off-site, they were mostly interested in using that black soldier fly technology on their own premises rather than transporting it to a centralized facility. So these are really the qualitative results, because we didn't have enough information to really quantify, okay, what is the cost at which this becomes more or less attractive. The final result that I'm going to show is in this wide range of things that we did in this project is the market research amongst end users. So our economics team looked at, well, once we've developed this fertilizer, is this going to be attractive to sell on a market in Australia? And because of the potential volumes produced, we focused on the wholesale market for farmers, so dairy farmers, horticulture farmers, potentially even grain growers. Was the end users that we targeted. And the picture that you see on the slide here is a range of products. These are all US-based products where they already have started selling insect frass as a fertilizer, mostly to home growers. So my presentation would not be complete without a choice experiment. So I'm showing you here the type of experiment that we did to figure out whether these end users were interested and willing to pay for using a black soldier fly frass product as a fertilizer. So for those of you who have not seen a choice experiment before, I'll briefly explain what you're looking at. So this is a choice question that we're using, and we describe a black soldier fly frass fertilizer product in this question by means of 4 characteristics. We had different forms of the fertilizer, being fine particles, liquids, or granules. We had different levels of organic carbon content, ranging from 0 to 60% of the product. And those were the values that we observed in our trials. And then different levels of NPK content. So that was to compare it directly to a synthetic fertilizer, ranging from very low to medium. And those were expressed in a range because it's a little bit variable. And then at the bottom, you can see a price. So the theory behind this choice experiment is that people choose one of the 4 options that they're shown, and they're asked to choose their most preferred one. And through that choice, they make these implicit trade-off between the levels of the attributes and the cost. And then we can use econometrics to evaluate, well, what are farmers willing to pay for the different levels of these three attributes. And we narrowed down these attributes based on a range of literature review, focus groups, interviews, a very typical process for doing choice experiment. I'm not going to show you the choice experiment tables and results, more the final conclusions of that choice experiment, which was that we had about 100 people responding to our survey, and not all of them finished the survey, but the ones that did all said that they were interested in this black soldier fly frass. They were all keen to see it, to maybe trial it, depended a little bit on the final cost and the final nutrient composition. But they weren't inherently averse to using insects as a fertilizer. However, because of the low NPK content, but also the low bulk density, which means that the transport costs are potentially high, it's unlikely that this product is going to be competitive with current synthetic fertilizers. But who knows, if synthetic fertilizer prices go up even more, then maybe that decision process will change. I was honestly quite surprised that everybody said, yeah, I wouldn't mind trying this. We had multiple options, including a no, I don't want, I'm not interested, and nobody ticked the no, I'm not interested. Potentially because of the current high fertilizer prices. Now, looking back at the different characteristics of the black soldier fly fertilizer that we presented, the respondents to our survey had a higher willingness to pay for products that were granular rather than super fine particles. There was also a group that liked the liquid, which is probably the horticulturalist, but the granular product was preferred on average, probably because on average farmers use spreaders or air seeders to spread their fertilizer, and a fine particle cannot be spread through that machinery. So you want something that fits your existing machinery, right? They also really liked the organic carbon content. So potentially this product could be marketed as something that increases the carbon or adds organic carbon to your soil. And then we found that there were different groups in our respondents. Some didn't mind the fact that it had a low macronutrient content, but most respondents wanted at least a medium level to be convinced that this was a product that they'd be interested in buying. And I tested lots of different respondent characteristics in the models, and the one characteristic that explained preferences was whether the respondent was what I call an alternative farmer, and that is people who say that they are a regenerative farmer, or an organic farmer, or a biodynamic farmer, rather than I'm a conventional farmer. So those people who said, oh, I'm a bit of an alternative farmer, were more interested in using this, which makes sense because they're already exposed to alternative fertilizers. So the message from that socioeconomic research is helping to paint a picture of what the potential market would look like. So if we were to develop a fertilizer product targeted at these alternative farmers, with a granular product with higher carbon content and at least a low but hopefully medium macronutrient content. Now, I'm not putting up the willingness to pay estimates for these individual characteristics because we didn't evaluate what the product willingness to pay would be, and you can't really add those up very easily. But it ranged between sometimes up to maybe $900, $1,200 per ton of product. depending on the NPK content and whether this farmer was an alternative farmer or not, which is probably comparable to current fertilizers of current composts that farmers could use, although it's still lower than some retail prices that I found for fresh fertilizers, which range from $1,500 to $2,500 per ton. So those costs probably need to come down for a market really to take off. Now, final conclusion is that this project has mostly been about that proof of concept technology, that we can use black soldier fly farming to process livestock waste, and that the resulting fresh product could be used as a soil amendment or fertilizer that enhances the sustainability and circularity of agricultural production. So I'm very much hoping that we can continue this line of research with maybe the CRC for net zero agriculture or other funding opportunities to, first of all, see if we can develop BSF technology on farm so that these individual, especially intensive livestock systems can use this black soldier fly, maybe meat processors, to help them with their waste management and reduce emissions and volumes of waste. But another important research step, or maybe even more extension and outreach step, is working with policymakers and regulators, because at the moment there is no regulation around black soldier fly fertilizers. There is no classification of that product, and without classification we can't market the product, because we don't know whether it's a waste product, a fertilizer product, or a compost product. And those regulations differ per state in Australia. So now that we're a bit closer to knowing what this product looks like, probably a next step should involve those policymakers to start getting some regulation in place and classification of these products. And I'll finish there and open the chat to answer some questions. So shall I keep sharing my slides, Caitlin, or?
That's up to you. If you'd like to keep them there, just flick back if people have questions, you can, or you can just cut it out, because a few claps coming in. Yes, I think everyone here is echoing my sentiments. Thank you for a really great seminar. It's really nice to see the overview and the sort of key findings from the black soldier fly project. I myself have seen little pieces of it here and there, but it's really nice to see it all sort of come together and what you've achieved as a team. I think it's really great, so well done. If anyone has questions, I noticed a few were popping up in the chat throughout Marit's talk, but if you have questions you'd like to ask in person, then do feel free to pop your microphone on or your video as well, so that you can ask them in person.
Yeah, I'll answer Michael's question, ask the cost of fresh. So that varies. Oh, I didn't stop sharing, sorry. So the cost of fresh varies for different products. At the moment, the only fresh being sold online that I could find was in smaller packages, and we did call a couple of companies that sell fresh and said, okay, what would be the bulk cost? And that ranged between $1,500 and $3,000 per ton of fresh. Some mix it with biochar, and varies, but those costs were all within that range. And honestly, there is no product available for the large-scale agricultural markets, retail markets at the moment. So I think it's going to be a little bit of trial and error, a bit of a market demand and supply. What would be the best price to sell this product in the market?
Yeah. So I'll go through and give them a thumbs up once they're answered. But Louise Barton had one, and I'll speak it out loud for the benefit of the recording. But she asked if you could provide the units for the greenhouse gas data provided for carbon dioxide and nitrous oxide emissions and how these data were collected.
I am looking at this now. Kilogram. Oh, I have to go through my slides. What I included in the slides. Let me just open that. So I received the updated information recently in kilogram per hectare per day, and it was a gas flux rate in jars. Can we see who else is online? Is Jen or Sasha online? Yes, Jen.
I think Jen was.
Yeah, Jen's online. Could you provide details on the greenhouse gas trial, Jen? Because I wasn't intimately involved in that one. Maybe not.
Maybe looking it up herself.
Yeah.
If you can, Jen, and you're listening online and even pop it in the chat, that would be great.
Hi, sorry, I couldn't work out how to unmute my microphone.
I'm
on my phone.
I'm looking
Hi,
at the
everyone.
flux results in the report, but
So they were done in the soil was incubated in glass jars with and then taken the gas samples at each time point over that study. So it was so I wasn't there for the experiment, but my understanding is that they basically sealed them off for 2 hours and then collected how much gas was produced after that time. And that was done, at each time point in that data set.
So I can quickly share the results that we are writing up in the, that's the benefit of having an online seminar. So what you see on your screen now is our greenhouse gas trials that are being reported in the final report, but that's due in a couple of days. And you see CO2 fluxes over time, methane fluxes, and N2O, which shows similar. I have no idea whether these numbers are high or low or just average, but it shows that same pattern as what I had in the table, that manure has the highest emissions, then FRES, and then the urea and control here, urea and control the lowest.
Thanks.
So if that answers the question, that.
Thanks, Marit. That looks good. Some really nice data. Don't mind, I might send you some thoughts on how to present that data so that it's when someone that works in that space looks at it, the units are comparable.
Thank you.
Well.
I'm sure that maybe Sasha and Jen can work with Louise when that report gets turned into a publication.
Yeah, Louise, flick us an email and it'd be good to have a chat about it. And with Sasha as well. Yeah. All right.
Nice data.
So the next question is, if this were to be done primarily on site, what happens following pupation? I don't really understand that question, Olivia.
I'm here, I can answer.
Yep.
So we propose mechanical separation after the processing is done. So on the presentation, Marit showed that after 7, 14 or 19 days, the process would be completed. And after that, we would implement a mechanical separation on site. So then we can kill the larvae or pupae. So there is no fly emergence, which is what probably scares the farmers, having flies around.
Sorry, question. That was what I was wondering. Just because I was like, oh, there would be so much emergence of flies, especially if you're using it on such a large scale. So perfect, thank you.
No worries.
That's thank you for that comment. I had not yet considered that. And then Juan has a long comment that I need to read. It's the main idea to provide the eggs or larvae to the farm. Also, does this project involve mostly delivering the flies to the farms or the waste to a processing facility? We have not gone into that yet. We're just looking at the technology itself at the moment. We were hoping to go into those sort of questions, those more logistics questions, but given that farmers had no idea how much it cost, and given that we were still actually developing the technology of processing the waste at all, we didn't end up looking at those sort of logistics. Would the farmers be more interested in using the technology to manage their waste rather than a soil amendment? Well, that's a comparison between two different groups of stakeholders that I don't think is that relevant, because we need both. I think logistically, probably having a central facility, and also given the amount of knowledge and expertise you need to even grow these larvae and also process them and then separate them, like what Sophia just described, having a centralized facility that processes the waste is probably the more achievable option. But this also depends on the cost that we are going to impose and regulations that are going to be imposed on the waste management and greenhouse gas emissions from waste in the future. So this is also partly preparing for that future and exploring possibilities.
Marit, a side note on that, we have options as well. Like once the research is finalized, and as you said, when we find out what's the best solution for farmers, if it happens that we have a decentralized model where farmers will have on-site the black soldier fly processing, we could deliver the neonates. So we wouldn't be delivering either flies or eggs, just the neonates. So it's the early stage of the larvae. So the farmers will only have to see that on the livestock waste.
So that's all those logistical next steps, I guess, that we now need to start thinking about. Now I'm looking at Ram asked about the percentage of completion, which I answered in the chat. Percentage of completion of the survey. Alternative versus conventional. So there was about 50-50. So we had, but the completion rate, we don't know because we only had the completed surveys. There was about 50% completion as well by farmers overall, but I didn't look at, well, where did 100% of the conventional farmers complete, but only 25% of the alternative? That's actually a good question that I'll have to have a look at. Ben White asks, can NPK be added to the FRES? Yes, definitely. We looked at different mixtures of FRES and in the tests as well. But also in the black soldier fly testing, like having different mixtures of waste, or but similarly you can have different mixtures of FRES, and like the one commercial product that I found that mixes FRES with biochar to make a different type of product. So it's just like any fertilizer product that you develop, right? You can mix it to what you need. Dung beetles might be a good substitute for beef and dairy as they bury manure into the soil. That's a comment, not a question. Of course, the Economist had to do that. And then finally, is there more messages? Yep, from Bede. What processes are in place to ensure that the FRES is free from any of the potential bad bugs from the livestock waste that could impact human health? For example, the composting sector has to comply with these Australian standards, and that means testing that product to ensure that it's safe. That's a great comment, Pete, and that is part of the tests that we have been doing, and also part of the tests that are being done in other areas in the world. I visited Wageningen University, for example, where this specific question is the main area of research, the potential health and environmental impacts of these black soldier fly products, both the larvae and the FRES. And the answer is it depends, because it depends on what some metals are. Some metals are not processed, but some other potential pathogens are eliminated by the frass. So it's it varies per pathogen, per virus, and also per potential heavy metal. In our example, we didn't look at, for example, processing livestock waste that had known pathogens in there. We only tested the waste before and after, and if there was, for example, E. coli, then that was eliminated, but we didn't purposefully feed them high rates of E. coli to see how much these flies could reduce them. And that research may be out there, but I haven't done that literature review. But the second part of that comment, that the composting sector has to comply with these standards, is exactly what I alluded to at the end of the presentation, that at the moment we don't have standards for this sort of product. So we don't know if it needs to meet the composting standards or some other standards, and the tests are quite expensive. So it needs to be a bit of a back and forth with regulators on, okay, what sort of standards do you think this needs to meet? Then we can make sure that it meets those standards and also do those tests.
Yeah, so recently, last year, the European Union has approved frass for farmer application, and the frass has to be dried at 70 degrees for an hour, and that will make sure that there is no pathogens in the product. So if there is more regulation in Australia, I'm sure that will be applied as well.
Yeah, exactly. So I didn't know that the European Union has just advanced their regulatory framework, but we will most likely follow that. And that's also the questions we get from the regulators. So what happens to the frass? Well, and then we go, well, it kind of depends what you want to happen. So if the European Union says, well, you need to heat it for this temperature and this long, that it's possible that the Australian regulators will go with that as well. There's a big focus in Europe on using larvae and the BSF larvae as a feed. So lots of research and also regulation going into that area. Not so much research into using the frass product or even the larvae product as a fertilizer product. Nanti is commenting on PFAS contamination, which we have not looked at all. And there is so many interesting research topics on this area. If we had an entomology lab in our school, they could be very busy with this topic for the next couple of years. I think I really enjoyed working in this multidisciplinary team that Louise also commented on. Learned a lot. So thank you, Sasha, for getting this project in and getting me involved. And the interesting challenges as well in a multidisciplinary project of understanding the different languages, the soil scientist and the soil microbiology. I never knew before I started this project that there is so many different types of soil scientists. Like, to me, there is soil scientists. Just like for you, probably there's economists. It's just all the same. But that was an interesting experience in this project. Are there any final burning questions? Because Caitlin and Michael need to go.
As I'm sure you do as well, you're a very busy person, and it's great to have you give such a wonderful seminar. So if there's any final questions, now's your time to ask them.
I think there was a question.
I'll get back to writing up the final report. Sorry, Sophia, you want to?
There was a question around household waste, but I would say that this was strictly around manure waste. So we have on the side other projects as well, but this was just manures or, well, livestock waste.
Oh, I see. Yeah, that was one's last question that I didn't answer. I think there's a lot of potential, and I'm really delighted that we have Future Green Solutions as an industry partner, hopefully with a lot more projects in the future. Yeah.
Great.
Thanks,
Well,
everyone.
with that, yes, thank you very much, Marit. This is being recorded and will shortly be available on our school's YouTube channel. And so, yeah, with that, I thank Marit for giving a wonderful presentation and for all of you for chiming in. Thanks very much.